We want to titrate 50 milliliter of 0.02 molarity HA, a weak acid, okay, with 0.1000 molarity sodium hydroxide. So sodium hydroxide performs as the strong base, right? HA is the weak acid. Now the pKa of the weak acid is 6.27, right? Now, can you calculate that before adding any base, what is the pH of the solution? How do you get the 6.97? pH equals pKa plus logarithm equation. That is when you have two forms in the solution, right? So now we're talking about before adding any base. So you're dealing with a simple monoacid solution, monoprotic acid solution. So it's basically this formula, right? Okay. And Ka is 10 to the negative 6.27. Multiply the formula formal concentration. But you cannot do negative logarithm directly because it's a weak acid. You have to set up the ICE. And by doing some approximation, you can use this formula. So this will be 0.0200. Mm-hmm. So it is 3.98. Okay. Do we get the same answer? Thank you, Shihan.
You're keeping the 366 because of the 6.27, right?
Yes.
Okay.
Okay, so this is the first case. What about the third case at the equivalence point? Now, first of all, we want to determine what the equivalence point is, right? Can you let me know what would be the equivalence point for this question in the unit of milliliter? Or in another word, how many milliliter of the sodium hydroxide you have to add to the solution to finish the titrating of the weak acid? Ten milliliter, right? Because it's basically M1V1, M2V2, right? So 50 milliliter multiplied by 0.02000 is your 0.1000 multiplied by V2. So V2 is 50.00 times 0.02000 divided by 0.100, which will give you 10 milliliter. Oops, 10.00 milliliter. Yes. Oh, this formula, this is from the ICE. Remember when we did calculation, the initial, this is F00. Change is minus x, x, x. E is F minus x, x, x. And x squared divided by F minus x is Ka, right? And we assume that F minus x is approximated as F. So x squared is KAF. X is square root of KAF. This is the how do you calculate the weak acid, that previous content. Okay, now we see that the equivalence point is 10 milliliter. It's actually, we don't really need this value for this calculation. We will be needing this value for the different condition, for the other two parts. But just to like give you information that 10 milliliter is the equivalence point. So at this equivalence point, how do we calculate the pH? Right, record what I just said. At the equivalence point, the HA is fully converted to A minus, so it's converted to a weak base system. Now the question is, how do you calculate the pH of a weak base system? So you will determine what OH minus is. We know that for this system, we can also set up the ICE, right? If you know the initial concentration, this is 0, 0, this will be X, X, F minus X, equilibrium, okay. And the same condition set, X squared divided by F minus X equals to equilibrium constant. So what is the equilibrium constant here? It's a weak base, right? So for this equilibrium, what is the equilibrium constant? Yes, it's Kb, which is Kw divided by Ka. Now the rest of the calculation is very similar to the first one, but the question is, what is F here? Or we should put it F nu because it's no longer the same F at the beginning. And why is that? Because the volume changed, right? So what is the F nu here? Taking into consideration the dilution. Why is it 0.1? So hope is right. You use moles divided by the new volume. How do we get the moles? It's actually the initial concentration multiplied by the original volume, right? That will give you the moles. And then you divide the new volume. What is the new volume here? I was wrong. You actually need this value, sorry. So what is the new volume here? $60, right? Because initially it's 50. You added 10 milliliter of the titration. The volume increased to 60. Now F is 0.02000. This is your new formal concentration of the weak base. Does that make sense? And then you will calculate your OH minus based on the square root of 0.02000 times 50.60 multiplied by KB, which is 10 to the negative 14 divided by 10 to the negative 6.27. Right? And after you do all this, the concentration of OH minus should be 1.67 sub 6 times 10 to the negative 5. And your POH will be 4.75 sub 4. pH will be 14 minus this value, which is 9.25. Okay. This example is from the textbook. So if you feel a little bit unclear about that, you can also refer to the textbook solution.